In the last session, we learned about correlation, rank correlation, and Carl Pearson's correlation coefficient. So, let us discuss in today's session that regression analysis. Basically, we already learned this kind of a concept in the third semester as time series analysis. In this, we are going to take a new session on regression analysis, which is some kind of a same part as we learned it in time series analysis. There we fixed one variable which is independent, that is time. Now we are not going to fix any such kind of a variable. Instead of that, we are going to consider any two variables which have a relation with them. Let us start learning this concept by understanding what it is going to be used. Basically, we are going to randomly take any two variables, maybe x and y. Let us define them as x and y. If they have some kind of a relation with them, that is positive, negative, or perfectly positive or perfectly negative, or any other relations which we already learned it in correlation, then using the relation between these two variables, if I know the value of one variable, we can find the value of another variable. Sometimes one variable will be taken as independent and another variable will be taken as dependent variable. Sometimes both the variables act as independent as well as dependent variables. So basically, to form a regression analysis, we require some kind of a equation which is going to be considered as a linear equation, which you have learned it in your school days. The linear equation which you have learned it in your school days is y is equal to a plus bx, where a and b are constants and y and x are variables. Specifically, y is dependent variable and x is independent variable. Now, since as I said, sometimes both the variables acts as independent variables and sometimes both the variables acts as dependent variable. So what we are going to do is, here in this concept, we are going to form a regression equation in such a manner that regression equation of, suppose that if I consider y as dependent variable and x as independent variable, then the equation is defined in this format. Okay, so here y bar and x bar are nothing but means of y and x variables, and byx is considered as a regressor coefficient. And suppose that if we keep x as dependent variable and y as independent variable, we are going to call it as regression equation of x and y, and it will be defined as x minus x bar bxy into y minus y bar. So all of you know already that how to calculate x bar and y bar. Let me write the formula of those again. X bar can be that is mean of x variable is calculated as summation x divided by n, where summation x is the total of all the observations given in x variable and n is the number of observations. Similarly, y bar can be calculated as summation y divided by n. Same theory is applied for this mean also. So what are these two? byx and bxy. These are called as regressor coefficients, and to calculate these two, we are going to use the logic or knowledge of Carl Pearson's correlation coefficient. The formula which we are going to use for calculating byx is very simple. It is byx can be calculated as n into summation xy minus summation x into summation y divided by, since this numerator is going to be same for both the regressor coefficients, denominator depends on whether you are calculating yx or xy. If yx you are calculating, then in the denominator only x factor will be using. If xy you are calculating, only y. So here we had yx, so in the denominator we are going to use only x factor. Similarly, if I am calculating xy, the numerator is not going to be changed. Only denominator. With respect to that, I am going to get the formula.